Hello everyone, let's start with the second lecture of control system. Today we will study about the translational motions, basically mechanical system. It is a mechanical system. It is composed of basically three types of forces. Number one is inertial force, second one is damping or viscous damping force, third is spring force. So in an inertial force, basically inertia is something which is contained in every object. It is composed because of the mass of the object. It is directly proportional. The force applied on any inertial mass is directly proportional to the acceleration of the object, which is governed by the equation F is equal to ma, where a can also be written as du by dt, where u is the linear velocity of the object. In terms of displacement, it can be equated to m times d square x by dt square. That is, second differential of displacement is equal to acceleration, which produces the force equal to ma, or m times second differential of x. Besides we have an object of mass m. Let us consider it as having a displacement of x, or it is having a linear velocity of u. The force applied on this mass m is directly given as F is equal to ma, which is equal to d times m, which is equal to m dot du by dt. The second force we will be talking about the damping force. Damping is the thing which resists any motion, or we can say it as that resist some velocity, or change in speed is governed by damping friction. Which damping is basically because of the fluid or some other type of mechanisms which resist the change in displacement. Then F, the force applied by any viscous force or damping force, is given by d times u, or d times dx by dt, where dx by dt stands for the change in displacement taken by the object. Suppose any object which is displaced by some amount under the frictional forces is having a damping which is equated to the amount of displacement, the speed with which the object is being displaced. Sometimes d is often related as b or simply f, where b or d means the same. The coefficient of damping is can be in various books. It can be written as a d, or it can be written as b. The meaning is the same. The b or d, the damping force is also denoted by b or d. Both the coefficients relate to damping force only. Now the third force, we talk about the spring force. The spring force is proportional to the displacement. The amount of displacement occurred in any spring is directly equated to the amount of force the spring is having, or the amount of energy the spring has. The spring constant is the force exerted by any spring is directly proportional to the x, or it can be equated as kx, where k is the coefficient of spring constant, where k is the coefficient of spring constant. Or k can also be equated as integration of u dt, where u stands for velocity. Integration of velocity is termed as the amount of displacement the object has made. Basically, while considering the damping forces or spring forces, the mass objects are not considered, because these things are being considered as an ideal case where the mass of any object is literally equated to zero. It simply means the object or the spring is not having any mass, or the damping coefficient is also not having any mass. It is only the object m, it is only the object which is having the mass. While considering these things, the ideality is to be considered. Next, in case of rotational system, these three types of forces are being modified as inertial torque, where F is related to torque. The equation of torque is J times d square theta upon dt square, where J stands for moment of inertia the object has in the system. Or this equation the torque equation can also be equated to J times d omega upon dt, where omega stands for the angular velocity. Considering of damping torque, अगर हम damping torque की बात करें तो damping torque is given by, suppose we have a damping coefficient of b, तो damping coefficient b multiplied by dx या d theta by dt, where theta represents my angular displacement. And similarly, in case of spring, it is equated with k times theta, or integration of omega d theta, k times integration of omega dt. That is the amount of displacement taken over a time. Now, comparing to analogous quantities, just in a similar fashion, electrical quantities can also be equated to my mechanical equivalent systems. Just like while considering the objects, the force is equated to velocity, or the force can be equated to current. If the force is equated to velocity, the analogous systems thus are known as force voltage analogy, whereas when the force is equated to current, the analogous system is known as force current analogy. Let us look at the table below. The table states if the force, it is having a mechanical translational system, the mechanical rotational system, the force voltage analogy, and force current analogy. It simply means the force is equated to voltage, or the force is equated to current. When considering of force voltage analogy, force is equated to voltage, or the torque is equated to voltage. While considering mass, it is equated to inductance. While considering viscous friction or the damping friction B, it is equated to resistance. Spring stiffness or spring constant is equated to 1 upon C. Linear displacement is equated to Q, that is charge. Linear velocity is equated, U is equated to I. Similarly, in case of force current analogy, force is equated to force current, the mass is equated to capacitance, viscous friction D is equated to conductance, that is G, that is reciprocal of R, 1 upon R. Spring constant, yes, spring stiffness is equated to 1 upon L, reciprocal of inductance. Similarly, linear displacement is equated to flux phi, and linear velocity is equated to voltage. Now, the important principle that governs these objects, the translational objects, is known as a D'Alembert's principle. According to this principle, everybody in the system is having a net displacement of force, net uh, equation of forces equal to 0 in any direction. For example, suppose we are considering a object static at one position. It is neither moving in any of the directions. The object is static. Object is having a mass. Then it is being considered according to Alembert's principle, the amount of forces resting on the object must be equal to 0. This is exactly what the Newton's third law states. If the object is moving, the amount of force resting on the object must be equal to 0, or it would be accelerated if say any external force is acting on any object. The similar fashion lies in the way if the object is at static position, the amount of forces resting on the object must be equated to 0. Basically, this principle is applied to make a free body diagram of any object while considering the force voltage analogous systems. Now, the transfer function. What exactly the transfer function is? According to my previous lecture, any object, any system must have an input, must have a controller, then must have some output. Whether it can have a feedback or not, it depends upon the type of the system. It may be an open loop system or it may be a closed loop system. While considering an open loop system, the system must be such that the open loop systems have input, the output, and the system processor or the system process. While the transfer function is defined as the output upon input in the Laplace domain. For example, let us consider a system is having an input, a process, and then output. The Laplace transform of output upon the Laplace transform of input is oftenly referred as the transfer function of the system. This can be done by taking the Laplace transform of the equations. The Laplace transform of equations simply can be taken by a simple order system, like replacing the d by dt system by s or integration of dt by 1 upon s. Suppose we replace the equation of the system by these things, the system would be converted into Laplace domain. Now let us talk about the impulse response of the system. Talking about impulse response, the input of the system must be equal to impulse or the impulse given to the system. The way or the system response to the impulse function is known as impulse response, where Rs or simply RT is known as del T, where del responds according to signals and systems. Del T is a very small signal of an amplitude 1 having an area of 1. Suppose we integrate the system over infinite interval of time, the integration of this such system would be equal to 0. So if we convert this system into a Laplace domain, that would be equated to 1. Then Laplace domain of RT is equal to Rs, which is equal to 1. Similarly, अगर हम निकालते हैं सिस्टम सी एस अपॉन आर एस, अगर हम सी एस अपॉन आर एस की वैल्यू निकालते हैं विच शुड बी इक्वल टू जी एस, तो आर एस अगर हम देखते हैं आर एस जो होगी हमारे पास 1 आ जाएगी, बिकॉज लाप्लास ट्रांसफॉर्म ऑफ आर टी इज इक्वल टू 1। अगर हम इस वैल्यू को पुट अप करते हैं तो द आउटपुट सी एस इज एग्जैक्टली इक्वल टू जी एस और द ट्रांसफर फंक्शन ऑफ द सिस्टम। तो impulse response of any linear system is equal to the amount of transfer function of the system or the system gain of the system. Hence the gt और the gain यानी कि हम कहते हैं impulse response of a linear system is exactly equal to the transfer function of the system. Hence अगर हमें किसी भी सिस्टम का ट्रांसफर फंक्शन इवैल्यूएट करना है तो हम क्या करेंगे, वी ऑलवेज टेक द इम्पल्स रिस्पॉन्स ऑफ द सिस्टम। द system responding to the impulse signal is known as impulse response, which is known as the transfer function of the system. Now let us take an example of a simple RC circuit. हम यहाँ पे लेते हैं RC सर्किट हमने दी हुई है। RC सर्किट में हमारे पास VI है, V0 है, एक R है, एक C है। तो अगर हम इसका इक्वेशन इवेल्युएट करेंगे तो हमारे पास इक्वेशन कुछ ऐसी आएगी, VI इज इक्वल टू R इंटू आई प्लस 1/C इंटीग्रेशन ऑफ DI बाई DT। तो अगर हम इस चीज़ को इवेल्युएट करेंगे तो हमारे पास इनपुट इक्वेशन हमारे पास मिल जाएगी हमारे पास, और एक आउटपुट इक्वेशन मिल जाएगी। तो आउटपुट अपॉन इनपुट इन लाप्लास डोमेन, यहाँ पे हमने जो इक्वेशन लिखी है दैट इज इन लाप्लास डोमेन, या इस चीज़ को हम डायरेक्टली भी कन्वर्ट कर सकते हैं। इस सर्किट को हम डायरेक्टली लाप्लास डोमेन में कन्वर्ट करने के लिए वी सिंपली रिप्लेस C by 1/CS and L is often replaced by S into L। ठीक है, तो I is replaced by IS, VI is replaced by VS, V0 is replaced by V0S। तो अगर हम यहाँ पे आउटपुट इक्वेशन V0S की इक्वेशन लिखते हैं तो V0S इज इक्वल टू 1/CS IS, यानी कि ये वाला वोल्टेज। सिमिलरली अगर हम VI ऑफ S की बात करते हैं तो दिस इज द अमाउंट ऑफ वोल्टेज अक्रॉस द रेजिस्टेंस प्लस द कैपेसिटेंस, यहाँ हमने इवेल्युएट कर लिया। देन दोनों चीज़ें हमने लाप्लास डोमेन में इवेल्युएट कर ली हैं। तो अगर हम ट्रांसफर फंक्शन की बात करेंगे तो हमारे पास ट्रांसफर फंक्शन हो जाएगा V0S अपॉन VI ऑफ S विच इज इक्वल टू 1/1 प्लस 1 बाय RCS। अगर हम RC को इक्वेट करते हैं एज टाउ तो हमारे पास इक्वेशन बन जाएगी 1/1 प्लस टाउ S, वेयर टाउ रिप्रेजेंट्स माय द टाइम कांस्टेंट ऑफ RC सर्किट। ठीक है, थैंक यू।